vector like this. So we have an x and a y, or two numbers. What was the x referring to? Yeah, left and right. And the y was up and down. If it's positive in the front, it's moving to the right. If it's negative, it's moving to the left. And if it's positive here, it's moving up, and negative, it's moving down. So we've already done vectors at that stage. A vector is something called a it has both a magnitude and a direction. So it has a kind of distance and a direction. Phone? Yeah. Thanks, Pat. Okay. So definitely we know how far it goes, and we know the direction of it as well. Normally you just have a point which just shows you where something is. So we know the direction. So what is the vector that links A and B here? Can anyone think they can write what would the vector from A to B? How would I get from A to B? I think it might be 3, 2. So to go from A to B, we go 3, 2. So that is called the vector AB. It's a distance and direction. We go 3 over 2 up. It's exactly 3, 2. What's the vector BA? Is it also, if I want to go from B to A, what is? Yeah, it's the exact opposite. I need to go. Fancy word for it? Oh, it's not a reciprocal or something like that. No, yeah, I know, yeah, good thinking. It's not a reciprocal. Okay, so notice there that AB is equal to minus BA. It's just the opposite way around, or you can flip those around. Okay. There is another way of dealing with vectors with no numbers at all. We just discuss distance and directions in kind of theory. So if we have a parallelogram, it's going to start with a parallelogram here. We have these corners A, B, C and D. We've got to go in clockwise direction. They say, right, let's say the vector AB is, we just shorten it down to the letter A. And the vector BC, we shorten down to the letter B. Okay, and we want to find, right, how do I write it with these two letters? How do I write B? How do I get from B to A just using these two letters alone? How do I get from B to A? What would it be? We can only use these two letters alone. And maybe you could see that that would be negative A. So if A to B is positive A, going that direction, B to A would be negative B, going the opposite direction. What would be the vector from C to B? BC, going this way, B to C is a positive vector B. So C back to B would be the negative B vector. So direction does matter. Whereas if that was just the distance I was dealing with, they would be the same. But direction does matter. If it's the opposite direction than the one you're looking at, it's going to be a negative. How do I get A to D? Is A to D, so that's this vector, the same as this? Yes, it is. It is exactly the same. It's the same vector. It's the same distance. It's the same direction. It's not in the same place, but the vector is a distance and direction. It is the same distance and direction, so it is also B. C to D, that's this one. What's C to D? We have to compare it to A. Is it the same? It's similar. It's not exactly the same. It's negative A, isn't it? It's gone this way, isn't it? C to D. C to D is the opposite direction from A to B. So it's actually a negative A.
Would we like ever get absolute difference?
Yeah. But with a bit of practice, they'll become quite easy. With a very first look at it, and maybe you're kind of getting it, which is kind of where we want to be at the moment. All right. They've created some sort of a pentagon in this second question. It's not a regular pentagon, so these distances are different. So we have A, B, yes, C, and D. They want to say, instead of writing this combined vector, what is one quick way we could write that? So let's look at this journey it's taken. It's gone from A to B and then B to E. So we've gone from A to B, then B to E. So how could we get from the start point to the finish point with one vector? A to E. Yes, you see that? We can just have gone straight there. So that is the same as A to E. All right, let's do another one. This long one here, DC plus CA. So we'll be thinking about the answer to this, plus AE. Let's look at the journey this one takes. We start off at D, and we go to C. Then we go across here to A, and then we go to E. So we start here, and we finish here. Yeah, we can go D to E. So you're noticing the first letter and the last letter, if they join up, CCAA, will just be the combined vector. The first letter and the last letter. So AE here, DE here. Yeah, Luke is already thinking about the next one. So we got this journey, which is a bit of a pointless journey, but it's a journey. C to B. CB, then we're at B, you go to D, and then D back to C. Nothing. There is no vector for that. It has no distance, no direction. It is just a point. It is not a vector. You haven't moved anywhere. Vectors are all about distance and direction. If you haven't gone anywhere, you've gone zero. So we can do that journey again. If we start at C and finish at C, you've gone nowhere. Okay. So we're more used to it in this form, the kind of numbers form, and maybe you prefer it like this because we can actually see the numbers where these things are positioned in space, and therefore we can talk about a move from C to D might be a move of minus 2, minus 3 or something. We can talk about the exact things rather than talking about somewhere in space. And that thing that we know already is called a column vector. So that XY thing, like 5, 2, that's called a column vector. Okay? This is how we'd use column vectors from now on. We're going to look at these 2 points, L, minus 2, 3, and M, 4, 1. Okay, we're going to sketch this. You don't always have to sketch, but let's have a little look where these points are. Minus 2, 3 is about here. That's L. M is 4 over 1 up. Okay, so something like this. Okay, our 2 points. So they want to know how to go, and first one, from L to M. What distance and direction do I need to go to get from L to M? Yes, so we talk about, right, how far we obviously go this way and then this way. So we've gone 6 boxes to the right and we've gone 2 down. So 6 boxes to the right, 2 down. So we.
Would you just do the second n minus L?
Yes, to formalize the process, you could write these points, if you like to write them. If you want to write it like this, you could write it as this is called a position vector, the position, so 4, 1, and you go, right, how do I get from here to here? Well, I end up, how do I get from here to here? It's 4 minus 2 and 1 minus 3. So I just subtract them, yes. Or I think finding the difference might be easier than formalizing. You just think about how I get from one way to the other. How I get from this x-coordinate to this x-coordinate, I go up 6. How do I get from the y coordinate to the y coordinate? Oh, I go down 2. So that might be just easier than formalizing it too much. All right, how do I go the opposite way then, from M to L? It would make sense if it's the exact opposite. They're both. And you can do that. Okay, how do I get, oh, I need to go back 6 to the left, so that's negative 6, and up 2 from this position. So a back 6 to the left and up 2 is that vector. Okay, let's look at further examples. So we have this new one with 2 new points. Maybe we'll try and do this without a diagram. If A is 2, 3, so that's its position. B is 4, 2. I want to find how to go from A to B. What's the vector from A up to B? So the x coordinate is increased by 2. And the y coordinate has, from A to B, if I want to go from negative 3 to 2, increased 5. If I want to go the opposite way, so B to A, we are getting there. Negative 2, negative 5 would be the opposite vector to that. Go backwards to backwards 5. Okay. What happens if I add 2 vectors? So if A is some journey from going 2, 5, and B is another journey, 1 minus 3, what happens when I add A to B? You can think about this with a diagram. If I start here at A, and I go over 2, up 5, and I'm at this position, and then I go a B journey of over 1, down 3, where have I ended up? So I've gone there and there. I've combined the 2 into this triangle, or this vector. So what is that? So perhaps I would need a scale for that, but it's, what was your answer, Pauline? It is 3, 2, yes. It is just 3, 2. So I would just add these columns together, 2 and 5, plus 1 and minus 3. 2 plus 1 gives 3. 5 plus minus 3 gives 2. And that does this process for us without even having to think about it. So a vector A, if it's going this way, and a vector B, if it's going this way, if I add those together, A, B, I get this vector, A plus B. It's that one. Yeah.
If it was like A minus B, you get an A minus B.
Yes.
Question.
Yes. What do you think it's going to be?
1, 8.
Okay. So A minus B, you're looking at 2, 5, minus 1 minus 3. Is that equal to 1, 8? The answer, we hope, and it is. We just subtract. 2 minus 1 is 1. So you go 2 right, and then you go back 1. You've just gone 1 to the right. 5 minus minus 3 is 8. So it just follows the logical laws of numbers. If I'm adding, I just add the x components. If I'm subtracting, I just subtract the x components. What it would look like in this diagram is if I've gone A, I go back B like this. I go the opposite direction. So that would be A, that's B, and this is A minus B. Okay, so maybe we can do these now without a diagram. We have new ones. So we have this P vector, 3 minus 2, and we have a Q vector, 1, 4. What do we think P minus Q is going to be? 3 take away 1, so P minus Q. I'm going to just write 3 take away 1 is 2, and minus 2 take away 4 is minus 6. What about if it's the other way around? We have Q minus P. Is it going to be the same answer? Just to make sure we line them up correctly, let's write them the other way around. 1 minus 3. Natalia is worried about a science test. Minus 2, 6. It's the exact opposite. Okay? The magnitude of a vector. So what is the actual length you have gone when you've gone this journey? It's as simple as Pythagoras' theorem, yes. When we go a journey of, let's take the second example here. We got 5 minus 2. What is the magnitude of this? The magnitude or the length of this? If I've gone 5 boxes to the right and I've gone 2 down, I've created a right angle triangle. Well, I want this length. That's the magnitude. From here to here is the length of the vector, how far you've actually gone, the distance. So the magnitude is using Pythagoras' theorem. It's just 5 squared, 2 squared, square rooted. So because this is the hypotenuse of a right angle. So the magnitude of this, yeah. No, it's something you're going to remember pretty quickly, hopefully. 5 squared plus minus 2 squared, square rooted. 5 squared. Now, you can keep this as a positive or negative because it's going to be squared anyway. So it's not going to matter. But this gives the magnitude. So you don't have to draw it. You can just put in the numbers. It's going to end up being squared because it's positive. So it's square root 29. That's a surd that I can't get the square root of, so I'll just leave it like that. So to get the magnitude, use Pythagoras' theorem. So that is the distance of a vector, how far you've actually gone. Okay. What happens if we multiply by something called a scalar? So a scalar is just a normal number. So if I multiply a vector, let's just use A and B before I use this example here. I have A and B here. What is 2A? Twice A. It is 410. So 2A, if you want to write it, is twice 2, 5. You can write it like that as well. That 2 is applied to both directions. It would be an enlargement if you think about it. It gets twice as big in both directions. There's no invariant, if you remember that from your transformations. That becomes 410. Instead of going over 2, you're now going over 4. Instead of going up 5, you're now going up 10. That's called a scalar multiple because this has no direction, this 2. It just doubles something. It's just only a scalar. Okay, let's look at the example on the board. They're given 2 new vectors. R is 3, 2. S is 2, negative 2. What is twice R plus an S? Twice this one plus once that one. So twice this one is 6, 4. Can we see that? Double that, double that. Plus 2 minus 2. What does that create overall? 8, 2. Okay, and I think this is the last question. I'm not going to do anything else newish. If I want to do these 2 combined, this one is 3, 2 from here, minus twice this one. So 4 minus 4 is twice this one. Double both directions. And then I just do 3, take away 4, minus 1. 2, take away minus 4, 6. Okay. Some of those concepts I will go through again on Tuesday because there's a few people missing. I will have to go over it again. There is some vectors work on my maths, but that's not due until Thursday. You're more than welcome to do it now. Remember, you've 2 No, you've one written homework